Welcome back, learners. So in this lesson, we will look at the first theorem. We've got 6 theorems in total for grade 11. So we'll look at the first one. So here's what the theorem says. The first one, it says the line drawn from the center of a circle perpendicular to the chord bisects the chord. So you must first understand what is a chord. We covered that in the previous video. Said it's a line from the circumference to the other end of the circumference, and it doesn't pass through the center. Just to recap. So now this is saying that, let's break down this theorem. So it says a line drawn from the center of the circle. So I've got the first condition, line drawn from the center of the circle. Maybe do this condition 1, and then that line is perpendicular to a chord. That is condition 2. Then we conclude that that line bisects the chord. So we've got conditions which are 2. Then we make a conclusion based on that. Okay. Just put this in a diagram, one condition at a time. So first we've got a line drawn from the center of a circle. So we need a center here, and it's always normally called O. So we've got a line drawn from the center. Also need to have a chord. I'm going to construct a chord here, which I'm going to call AB. So this is saying that if you've got a line drawn from the center of the circle, let's draw a line from the center. Here's a line from the center O, and that line is perpendicular to the chord. This is condition 2. So we draw that line, it goes to the chord, and it is perpendicular to a chord. So we've got now 2 conditions. We've got a line drawn from the center of the circle, and that line is perpendicular to a chord. That's condition 2. What do we conclude? We say now that line will bisect the chord. What does bisect mean? It means that, so bisect, so you know that bi means 2. So bisect, it means to divide into 2 equal halves. So I'm going to put that here. So divide into 2 equal halves. So now we've got a line drawn from the center, condition 1. Condition 2, this is perpendicular to a chord. What do we conclude? We conclude that that line bisects the chord, meaning that it divides the chord into 2 equal halves, our chord being AB. So we're going to have C here. And then now this line OC is going to bisect the chord. So it's going to make AC to be equal to CB. See, now divided the chord AB into 2 equal halves, being AC and CB. So all in all, if we are given that OM is perpendicular to AB, or in this case it's OC, a line drawn from the center perpendicular to a chord, our chord being AB. What do we conclude? We conclude that AC is equal to AB, which is the same. AC is equal to CB, which is the same as saying that OC bisects AB, or it divides AB into 2 equal halves, or it makes C to be the midpoint of AB. All those 3 statements, they mean the same thing. That's all what theorem 1 says. You must have a line drawn from the center, and that line must be perpendicular to a chord. Therefore, then that line is going to bisect the chord which means it's going to divide your chord into two equal halves, meaning that if AB was equal to 10, if AB was equal to 10 centimeters, then AC is going to be 5 and CP is going to be 5 because we divided by 2. Alternatively, if you were given AC, that AC is 7 centimeters, therefore it means that CP will also be 7 centimeters, making AB to be 7 times 2, which is 14 centimeters. That's how we use this theorem. Just look now at the converse. The converse now is the reverse. We're now reversing. So in the converse now, what we say is we are now given the line drawn from the center to the midpoint of the chord. Then we conclude that that line is perpendicular to the chord. So for the converse, we're now given a circle, still given a center and a chord, center O, chord AB. We're given a line drawn from the center, and we create a C here. And then for the converse, we are now given the following. We are given, we've got a line drawn from the center, and then we are given that that line bisects the chord, meaning that we're given that AC is equal to CP. What do we conclude? We conclude now that OC is perpendicular to AP. So we conclude that OC is perpendicular to AP. See, now we are reversing. Here we were given that OC is perpendicular to AB. We then concluded that AC is equal to AP, or that AC is equal to CP, I mean, or we concluded that OC bisects the chord AB. For the converse now, a converse just reversing. For the converse now, we are given a line drawn from the center, and we are given that that line bisects the chord. So given that AC is equal to CP, what we conclude? We conclude that OC is perpendicular to AP, meaning that there is a 90 degrees here. Difference between a theorem and a converse, just reversing. and then for this theorem, as you can see, it gives us 90 degrees here. So it's gonna give us a right angle triangle that you can use Pythagoras. Why? Because we can construct a radius here. Radius, we said it's a line from the center, a line from the center to the circumference. So we've got a radius here. We've got a radius. So see now we have created a right angle triangle, and now we can use Pythagoras to calculate the radius or any other side. Also, to note that OB is the radius and OA is the radius, so OB is equal to OA because radiuses are equal in a circle. In the next video, we're going to look at examples of how to apply this theorem.